When we're factorising trinomials that have a coefficient in front of the squared term, we first of all need to multiply that coefficient by the constant at the end. So 2 times 5 gives me 10. Now I'm looking for two numbers that will add to give me 11 and multiply to give me 10. So 10 times positive 1 gives me 10, and 10 plus 1 gives me 11. So those are my two numbers. Now on the next line I need to first of all write that first term down exactly as it is, and then I split the middle term into the sum of two terms. So I'm going to say plus a plus 10a in the middle, and then plus 5 on the end. So we only use this 10 here to help us choose our two numbers. That then allows me to group these in pairs. So the highest common factor of 2a squared, and a is a. Then in brackets I need 2a plus 1 to give me back those first two terms. Factorising 10a plus 5 gives me 5 outside of 2a plus 1. So we should notice here that we have a repeated factor, which means we now can put this into brackets. 2a plus 1 times a plus 5, all in brackets. So that's how we factorise that first one. We use the same process here. So 5 times 2 again gives me 10. Now I need two numbers that multiply to give me 10 and add to give me 7. 2 times 5 will give me positive 10, and 2 plus 5 will give me 7. So I break that middle term into sum of two terms. So 7y is made up of 5y plus 2y. And then we put that constant on the end. So all I've done there is I've written 7y as the sum of 5y and 2y. That then allows me to group in pairs. Highest common factor of these first two terms is 5y. Then inside brackets I'll need a y plus 1. The highest common factor of 2y plus 2 is 2. So I need a positive 2 outside of brackets, and then inside the brackets y plus 1. I've got repeated factors here, so I'll write those in my first set of brackets, and then in the second set of brackets I leave what's left over, which is the 5y plus 2. And that's that expression fully factorised. Have a look at another. So here I've got a negative 5 in the middle. We start this process the same way. 2 times positive 3 gives me positive 6. So that's the number now. I need two numbers that will multiply to give me positive 6 and add to give me negative 5. Negative 2 times negative 3 will give me positive 6. Negative 2 plus negative 3 will give me negative 5. So that's my two numbers that I use to write that central term as a sum of two terms. So first of all we write down that 2b squared minus 2b minus 3b plus 3. Grouping in pairs, the highest common factor of 2b squared minus 2b is 2b. Then inside the brackets I write b minus 1. Grouping the last two terms in pairs. The highest common factor of negative 3b and positive 3 is 3. And then I need a negative b plus 1 to give me back my expression. We can see here that I've actually made a little bit of an error, so I need to tidy that up a little bit because I need these two to be identical. So 2b outside of b minus 1. What I'll do is I'll take that negative outside, so we get a negative 3 on the outside, which means all the signs inside will change. And now I have a repeated factor. I can factorize by putting that b minus 1 in brackets and then multiplying that by 2b minus 3. You have one more here, so that 2 times the negative 6 will give me negative 12. I need two numbers that are going to multiply to give me the negative 12 and add to give me negative 11. So negative 12 times 1 gives me negative 12, and negative 12 plus 1 will give me negative 11. So I get 2y squared plus y minus 12y minus 6, and now I group in pairs. Y outside of 2y plus 1 minus 6 outside of 2y plus 1. Can be a good idea to just check your signs there by multiplying out. So when I multiply that negative 6 by the 2y, I'm going to get a negative 12y, and I multiply negative 6 by positive 1 and I get negative 6. So that tells me my factorization is correct. Repeated factor 2y plus 1 goes in the first set of brackets, and then y minus 6 in the next set of brackets. And of course those brackets could be written the opposite way around. I hope that's helpful.